In the second problem, it says we have 4 feet of wire. So don't laugh at my picture, that's my wire. It's my 4 feet of wire. And it needs to be used to form a square and a circle. How much of the wire should be used for the square and how much of the wire should be used for the circle to enclose the maximum total area? Okay, so I want to maximize the area of the square and the circle. So let me go back and label this square with things that I know. I know that the sides of the square have to be the same. I don't know what they are, so can I call them both x? And so if I'm using area of the square, then I would have x times x or x squared. If I knew anything about the perimeter, then I would do x plus x plus x plus x or 4x. I also have a circle. I don't know anything about the circle. Let's say we have a radius, we'll call it r. I don't know what the radius is. If I want to find the area of the circle, the formula for area of the circle is pi r squared. And for perimeter, or circumference is what they use for circles, would be 2 pi r. So if I want to maximize the area of the square and the circle, then I'm maximizing the area of the square, x squared, plus the area of the circle, pi r squared. And so this is my primary equation that I want to optimize. I want to find the maximum area. Okay? The problem is we have x's and r's. We have too many variables. So let's go back to the information that they told us. It told us in the problem that we had 4 feet of wire. And so 4 feet of wire can be used to make the square or the circle or the perimeter kind of. So I'm going to use my perimeter as my secondary equation. So I know the perimeter of both of them combined would be 4x plus the 2 pi r. And I know that the perimeter can be 4 because I have 4 feet of wire. And so plugging in the 4, I can use this equation now to solve for either x or for r. I'm going to go ahead and solve for r by subtracting 4x to both sides, by dividing both sides by 2 pi, and I get r equals 4 minus 4x over 2 pi. If you notice that all 3 of these can be reduced by 2, and so I actually get r equals 2 minus 2x over pi. So I'm going to take this and plug all of this in for r into my primary equation, so I only have one variable, giving me a new area equation of x squared plus pi times 2 minus 2x over pi squared.
What are you doing, Mom?
I'm recording this, baby. Hold on 1 second, okay? I'm sorry. I'm going to go ahead and simplify this a little bit more by factoring out inside here a GCF of a 2. So then I have 1 minus x over pi. So that way I can take this squared and distribute it. So everything on top and everything on bottom. So then I end up getting a new area formula that says x squared plus pi times 4 times x minus 1 squared all over pi squared. Okay. From there, I can reduce this pi and one of these pi's. I have then x squared plus 4 over pi times 1 minus x squared would be my new area formula. You could try and FOIL out the 1 minus x, but I'm going to go ahead and stop there and just go ahead and put that part of my calculator. This is the equation that I want to optimize so that I can find the maximum area. So I'm going to enter this into my y1. You might want to put parentheses around this 4 divided by pi. If you're back into your Zoom standard screen, you should be able to not only see your original graph, you should also be able to turn on your derivative and see your derivative graph. Okay? From my derivative graph, I want to figure out where my derivative equals 0 or does not exist. It should cross the x-axis once, and so if you can find where the derivative equals 0, you should get a critical value at x equals 0.560. 0.560. Okay. Again, we don't want to just check the critical numbers. We also want to check endpoints if there are any. Because I have restrictions on this problem, I know that there's certain things that x can't be. I need to figure out what those restrictions are and test those values. Okay, so going back up to my picture and my information, what values can x not be? Well, x is the side of my square, so I know I can't have negative values. So I know my domain restrictions have to be greater than or equal to 0. Okay, it can equal 0 because I could not have any amount used on my square. Right? I can have all the amount of the wire used for my circle if I wanted to, so x could equal 0. What can it not be, though, on the other end of the spectrum? Well, I know that we only have 4 feet of wire, and if the perimeter is 4x, well then x at the most can only be 1, so x has to be less than or equal to 1 to make sure that we don't go over 4 feet and then we don't have any negatives. Okay, so those are my 2 endpoints if you want to think of it that way. So I'm going to test in my area formula my endpoints and my critical value. All still using your calculator, so making sure your original graph is highlighted. You're going to do your second trace values, making sure that your original one is highlighted, plugging in 0 for x, you should get a y value of 1.273. Plugging in 0.560 for x, you should get 0.56. Plugging in 1 for x, you should get 1. And if we're looking to maximize the area, which one of those numbers are the most? Which one would give us a maximum value? Well, it looks like here, x equals 0 would give us a maximum value. At x equals 0, we will have a maximum area. But then let's go back and figure out what that means about my problem. If x equals 0, then that means I'm using nothing for my square, which means I'm using all 4 feet for my circle. All 4 feet of wire used for my circle. If I have 4 feet of wire and I want to maximize the area, well, I want to use all 4 feet of my wire for my circle. I don't want to use any of it for my square. Okay? Have a good Thanksgiving. Be safe. Do your homework, and I will see you on Monday.